Nice.
You're making that for helping.
No, I'm not. I said no.
Yeah, I'm saying
I said yes.
He gets excited.
Okay, I'm on page 222. Why do I all look so sad?
Chemistry.
That's why I told Abby to do chemistry class. He said, no, let's have it and then you can focus on your maths after. I said, no. Give me my time. When they come happy. When they leave sad. That's the problem. Right. Now, page 222, we have maximum and minimum values. There are much more to go through. Hopefully, we're done with it by today, right? So, we're looking at successive differentiation. So, answers to problems about differentiation can themselves be differentiated. This is exactly what successive differentiation means, and you must also be familiar with the notation. So, say for example, you have y is equal to x to the power 6. X to the power 6. Right? If I derive equation y with respect to x, I'm left with 6x to the power 5. Okay? This here is known as your first derivative. Okay? If I derive this equation, I'm basically deriving dy over dx, right? Because dy over dx is equal to that, I'm deriving that equation, right? So it's going to be d over dx again of 6x to the power 5. So this becomes d squared y all over dx squared. Okay? And then this becomes what?
That's the
30 x to the power 4. You know that, right?
Yeah.
Because remember, this here becomes, we take out the 6 d over dx x to the 5. This becomes 5x to the 4. 5 times 6 will make it 30x to the 4. This is known as your second derivative. You can derive this again. So you can take the derivative of d squared y over dx squared, should be the derivative of dx, 30x to the 4, and you're left with d cubed y over dx cubed, which is equal to 120 x to the 3. This here is your third.
So you can go on and select 0.
Yeah, you can go on until you're going to end up with something, because once you try to derive that 0, you're not going anywhere, right? But this is successive differentiation, right? When you continue differentiating on the equation, right? So this was your first derivative, this was your second derivative, this is your third derivative, okay? So, on the top of page 223, right? They're basically telling you that for the same thing, we're just saying that f of x is equal to x to the power 6. Remember, we write the function of, you write it as a function of the independent variable, right? So, your independent variable here is x, right? So, we wrote it as a function of the independent variable. So, another way of saying everything we said over here was, we could have said that f prime x is equal to this 6x to the 5. F double prime x is equal to 30x to the 4. F triple prime x is equal to. So another way of saying first, second, third derivative is with the primes, right? Where you add another prime when you're saying it. Okay? Same thing, you could have said y prime. So you could have said y prime, or f of x, you could have said y double prime. No, sorry, that's y. This is y prime. This is y double prime. This will be y. Okay? All of these notations could be the same thing. You could have said d squared y over dx squared. You could have said y double prime or f double prime x. Okay? All of these notations. You'll understand these notations, right? because we've done it before. Okay. So, one very important application of successive differentiation. Okay, so I'm not going to go through that part because they just give you an example of where it is. It's going to look like science work, and I don't want you to think that this is science in maths, right? So, I'm not going to get that part, right? The main thing I needed you to get from this whole thing about successive differentiation is that we can continue to derive even a derivative equation. So, this became a derivative, right? We can still derive on that derivative and get this. Can still keep on going. That's successive differentiation, and that's the notation of how you would write it out. Okay. And take down a picture. Let me just write this part here, right? Before you take a picture. Okay. Okay, now on maximum and minimum turning points. Okay, so maximum and minimum turning points, the stuff I'm going to mention is based on this graph that's over here. Okay, the stuff is on page 224. So the maximum point is defined as the point at which the function value or your y value is greater than any other point that's close to x. Okay, so that means that if a x gives you a y value, it's greater, your y value is greater than any other value of y. Okay, that's that, right? Your maximum value will be obviously your highest value of y for a value of x. Get that?
Okay.
Okay. On the graph that they show you, point A is found at small letter a and f of a. Okay, so they have this graph. Okay. The graph looks like. Oh, I keep this. Okay, so for that first point, what they're mentioning is that point A, that's point there, is found when your x coordinate is A and your y is at f of A. Okay? So the y values is basically a function of the x values. Okay? So that's what they're saying. Then they tell you that it's an example of a maximum point. Then they tell you if h has a low value, then f of a is greater than f of a plus h. Don't worry about that part there. What I want you to look is where they say d over dx of y is equal to f prime x. You're there, right? So the derivative of y is equal to a function, the first derivative of x is a positive value before a. So what they're basically referring to here is, you see a gradient coming up. Remember your first derivative we used to work on gradient. Remember we did first principles? We said m. Okay? So on this end, because it's sloping upwards, it's positive gradient before point A. After point A, it slopes downwards and it has a negative gradient. Okay? Then they go on to tell you that at a maximum point, the rate of change of dy over dx is negative and it decreases. And then they come to that point where they tell you that the double derivative is less than 0. No, I skipped a lot of steps there. I'm sorry, guys. See where they tell you at, after they tell you negative after a, m equal to negative. Can you see it? Right? And then they tell you at point A, at this point here, your gradient is equal to 0 because it's at its maximum point. If you draw a tangent there, so remember if this one here is increasing positively, and then on this end it's decreasing positively, decreasing negatively, and here at some point it's going to have to be 0. Okay? So that's what they're basically saying over there, where point A lies, and if you draw a tangent at the maximum point, your gradient will be 0. Okay? From this whole thing, guys, there's a whole lot of unnecessary theory that they tell you. Well, I basically want you to know this bottom part, right? See where it says to sum up. For a maximum or minimum point, dy over dx is equal to 0. Highlight that. So they need circle it, put a cloud around it. That's what I want you to know for maximum and minimum points. Right? In the bottom, to sum up, you see over there. Bottom of page 224. Right? For a maximum or minimum point, dy over dx dy over dx is equal to 0, or you could say f prime x is equal to 0. It's the same thing. Okay? The x values of the turning points are called your critical values. Highlight that too. If they ask you to calculate your critical values, they want to know the x values. Again, you'll see what it means when we do an example. Another important thing, to distinguish between a maximum or a minimum point, the second derivative is used as a test. Now you will work out your second derivative, and if the answer you get is greater than 0, right, you're going to see it in an example. If you get an answer that's greater than 0, it's a minimum point. If you get an answer that's less than 0, it's a maximum point. Those 3 points are very important for you to know when you're working on maximum and minimum turning points. You're going to see it in the examples, right? So, let's do an example, okay? So, they want you to calculate the maximum and minimum point of 1 over 3 x cubed plus 2x squared, and distinguish between them. Distinguishing between them means that when you calculate these 2 points, right, your turning points, which one is your maximum, which one is your minimum? That's what they want you to do. Okay? So how do we do this? So let's start to do it. Okay? So this is the equation that they gave you. I'm going to write it in terms of f of x, a function of the independent variable, which is x. Okay? So f of x is equal to 1 over 3 x cubed plus 2x squared. Right? Fine.
Yeah.
So for a maximum or minimum point, f prime x must equal to 0. So we need to derive this equation and then equal to 0. Okay? So it will be, if you derive this, what does it become? X squared 4x equal to 0. Do we understand that? Okay, because it's going to be 3 times this 1 over 3, which is 1, and then minus 1 over here will make it 2, so that's not x squared, and then 2 times 2 is 4, x to the power 1 minus 1, 2 minus 1 is 1. So I did the derivative. Okay, you let it equal to 0, and now you solve for x. Okay, to do this, we can just factorize, so you can say x into x plus 4 equal to 0. Therefore, x is equal to 0 and x plus 4 is equal to 0, x is equal to minus 4. Right? These two values of x, the 0 and minus 4, is your critical values. You're all with me? Anybody confused? Please communicate with me. Please talk to me.
No.
Okay.
Seems like that.
So you said it's called critical values because that's your x values, okay?
The x values you calculate when you derive your equation and then it equal to 0 is your critical values. Your first derivative values of x is your critical values. For your turning point, you take these x values and you substitute it back into your original equation, not your first derivative equation your original equation. Okay? So f of 0 is equal to, so I'm basically substituting 0 for the value of x. I get that, right? So this would be 1 over 3 times 0 cubed plus, no, 0 cubed plus 2 times 0 squared, right? And this would give you 0. And then if I do it for minus 4, it's going to be 1 over 3 times minus 4 cubed plus 2 times minus 4 squared. So what you get there? You could just calculate. You're going to end up with decimal. That's it, not a whole number. 10.6667.
Yes.
Okay, that's the value. So your turning points coordinates are 0 and 0 and minus 4 and 10.667. Anybody is confused with what I did so far? That's okay. So we've now calculated the maximum and minimum points. That same turning points here, because remember, for a maximum minimum point, these critical values are the x value of your maximum or your minimum points, right? And remember, your maximum from the graph I drew, if it looks like this, right? That maximum is found obviously at the highest point. Okay, and it will be the highest point will be where it turns to the max and then it starts turning in the other direction. Okay, so now we know our coordinates of the maximum and minimum, but how do we know which of these coordinates are the maximum and which of these coordinates are the minimum? Okay, because I know sometimes you may say like, okay, because this is on the negative side and this is on the other side, it's going to be positive or negative. Sometimes the graph may look like this, right? Sometimes the graph may look like that, or something like that, or something may look like, there's the same thing I drew here. Sometimes it may look, the opposite of this would be, and something like that, right? But somewhere along the line, you're not going to, it's not always going to be straightforward where you can look at the values of x and y and say that this is our maximum and this is our minimum, right? So how do you do it? So your test to distinguish is see that rule 3 of what I asked you to highlight, right? Your test to distinguish the second derivative, if it's less than 0, you have a maximum point. If your second derivative is greater than 0, it's a minimum point. So f of x is equal to 1 over 3 x cubed plus 2x squared. Agreed?
Right.
F prime x, or your first derivative, is x squared plus 4x. Right? Your second derivative would be 2x and 4. Okay? So that's our second derivative formula. So what we do is we take the x values, your critical values, and you substitute it. So f double prime of 0 is equal to 2 times 0 plus 4, and you get a number of 4. And for f double prime of minus 4 is equal to 2 times minus 4 plus 4, which is minus 4. Okay? Now, if you look at this, f double prime of 0 is greater than 0. F double prime of minus 4 is less than 0. From the rules that I told you, if it's greater than 0, it's a minimum. point. And if it's less than 0, it's in
This is gonna be confusing. So, how can you have a minimum that's less than 0? A maximum that's less than 0? And a maximum and a maximum that's more than I.
okay. That's what you do. Okay, to recap what I did. Okay? They gave you this equation and they asked you for the maximum and minimum points and distinguish between which one is the maximum and which is the minimum. Okay? So from the rules showed you before, you need to work out the first derivative and let it equal to 0 and solve for your values of x to get your critical values of the maximum and minimum point. So we call this equation in terms of f of x, right? And why we wrote f of x is because your independent variable is x. So it's a function of your independent variable which is equal to that equation. For a maximum and minimum point, your first derivative must equal to 0. So what I did was I derived that equation and I ended up with x squared plus 4x. Let it equal to 0. I solved for my values of x. So x equal to 0 and x equal to minus 4 are my critical values. To get that turning point or that maximum and minimum point, you have to substitute these x values back into your original equation. And I am able to get two coordinates. Now these two coordinates are my maximum and my minimum coordinates. Okay? But now how do I know which one is the maximum and minimum point? I do a test to distinguish which one is the maximum, which one is the minimum. So the test is you work out your double derivative or your second derivative, right? If your number you obtain when you substitute an x value in it is less than 0, you end up with a maximum point. If it's greater than 0, you end up with a minimum point. Do you understand what I did here?
Yeah.
Okay? Yeah, I told you.
As much as it's confusing, but you can understand.
Would we be able to show this graph?
Yes. Yes. Not the specific one, but then make your draw for cubic functions.
Okay. I'm just trying to imagine this thing very.
Come on, I'll call you.
Yeah.
Can I take it out?
Yeah.
Okay. Let's do another example where they tell you calculate the turning points of y is equal to ax squared plus bx plus c. Okay? They want you to calculate the turning points and distinguish between the maximum and minimum turning points. So let's convert it into a function of x. Okay? So this would become a function of the independent variable, which is x, ax squared plus bx plus c. And they want your turning points. So it's your maximum or minimum points. To do that, for a maximum or minimum turning point, or for a maximum minimum point, f prime x is equal to 0. Your first derivative is equal to 0. So if you derive this equation, what you end up with?
2ax.
Everybody understand? Okay. Now we let this equal to 0. So we need to solve for x, right? So x will be equal to minus b all over 2a. You all understand this?
Yes.
Remember this a, b and c are constants, is coefficient values, right? X is the term, the variable term. Okay? So now we solved for the critical value. This here is your What do we do after that?
Turning point.
You substitute it back into your original equation to get the y value of your turning point. So you would say equal to, and then you'll have a into minus b over 2a squared plus b into minus b over 2a plus c. Okay, now you solve it. So this would be a into minus b squared is b squared, right? 2a squared is plus minus b squared over 2a plus c. So this and that would cancel. You're left with b over 4a plus minus b squared over 2a plus minus b squared.
The B, the first B.
Yeah? Yeah. Yeah.
The first B.
Yeah.
It's not a square.
Sorry. Right? Okay. Now would you continue solving for this? You have to look for a lowest common denominator, right? Which would be 4a in this instance. So to get this to 4a, you would have to multiply here and here by 2a and multiply the top and the bottom, right? Yes? To get into a lowest common denominator. Your lowest common denominator is 4a,
Yeah.
right? So to get this to 4a, you have to multiply the top and bottom by 2a.
Yeah.
And, no sorry, 2, just 2. Yeah, so it's just 2 here. And on this end, to get that with the base of 4a, you have to multiply by 4a in the numerator, 4a in the denominator, right? Lowest common denominators. You okay? Avi should have never taken your first day. Never should have taken your first, honestly. B squared over 4a is equal to minus 2, no, minus 2b squared all over 4a plus 4ac all over 4a. And if you group it, it will become b squared minus 2b squared is minus b squared plus 4ac. Can leave it again, right? So your turning point is minus b over 2a and minus b squared plus 4ac all over 4a. So this has it has only one turning point. But how do you know whether it's a maximum or a minimum turning point? Do your test. So you know whether it's turning like down or whether it's turning up. Okay? Because remember this equation is an equation for what? From graphs?
Straight line.
Parabola. Right? And how a parabola looks is a parabola looks like that or like that. Right? So we want to see this point here and here is what we worked out here. We want to see whether the point we worked out is a minimum point or a maximum point. So to do that, you have to do a test to distinguish whether it's a minimum or a maximum. And what is the test? If your second derivative is less than 0, you have a maximum point. If your second derivative is greater than 0, you have a minimum point. So, your f of x is equal to ax squared plus bx plus c. Your first derivative is equal to 2ax plus b. Your second derivative will be equal to 2a. Now what does this mean? that value would be a positive value. For a value of a that's greater than 0, you're going to end up with a positive answer, right? Yeah, that's what they say. Yeah. So if a is greater than 0, your f prime x would be greater than 0. If I substitute a value of positive 1, 2, 3, 4 all the way to infinity, the number that I obtain is going to be greater than 0. You'll agree?
Yeah.
Right? So you would end up with a minimum. But if my value of a is less than 0, my f prime x would also be less than 0, so I'm going to end up with a. So what we basically did was we worked out formulas to basically state whether your graph would be. Once you have values in that spots, you just substitute it. Like if we had a value for a, b and c, we'll just substitute it into this equations here that we worked out to get a turning point. And then we just substitute it here to see whether it's a maximum or minimum. Right? Another thing, these values that you calculate, you see in the last question we did, we calculated a value for f double prime. For f double prime of 0 equal to 4. And f double prime of minus 4 is equal to minus 4. Those values mean nothing other than the fact that if it's greater than 0, it's a maximum point. If it's less than 0, it's a minimum point. It has no effect on your graph, how your graph will look. Right? It's mainly, or it's not a point on the graph. It will have effect how it looks because it's a maximum or minimum, right? But it's not a point on the graph. Okay? It's just used to distinguish whether your graph is at a maximum or a minimum at that turning point. Okay? Please don't confuse yourself.
Another calculation
What?
to find the actual point.
No, your x-intercepts.
Right? So your maximum point doesn't have a value.
It's the turning point.
Okay, then what you just said.
See, when we distinguish
So
in
that point that we get your turning points, those values, is your turning point value on the graph.
yeah.
Okay, you said Dr.
The double derivative, pay attention, the double derivative, when we worked it out, right? In the previous example, where we have in the bottom, test to distinguish, and then we said f of x is equal to 1 over 3x squared, bottom of page 225, right? When I'm testing to distinguish which one of my turning points were a maximum or a minimum, right? I did my double derivative, and I substituted a critical value into it of 0 or minus 4. And I got an answer of 0 and minus 4. And that told me which one was my maximum and minimum. That value of 0 and minus 4 obtained when I substituted the value into the double derivative formula. Does not have anything to do with the graph, besides the fact that it's telling me whether that point is maximum or minimum. My turning points are calculated with my first derivative. The second derivative part that I'm saying, it's not a point on the graph, it's just telling me maximum or minimum. Okay? Don't confuse yourself with it, right? So to recap again on this question, given an equation, they want to know the turning points and distinguish between which one is a max, or whether it's a maximum or a minimum. So you started off by, for a maximum or minimum point, your first derivative, you let it equal to 0. So I derived my f of x and I let it equal to 0, and I solved for my value of x. When I solved for my value of x, I obtained my critical value. Using my critical value and substituting it back into my original equation, I get the y value for my turning point. And my turning point is that critical value and that y value I calculated. Okay? So I obtained the turning point of this graph. But how do I know whether it's a maximum turning point or a minimum turning point? I have to do the test. And the test says that your second derivative, if it's less than 0, it's a maximum point. If it's greater than 0, it's a minimum point. And that's what I basically say. And understanding the method, you're understanding this one, right?
Yes.
It's allowed to take in because I'll be the chemistry first. But it's okay. Eh? Now to do another example. That sounds so sad. Oh my god. It's a Friday. You're writing tomorrow. It's supposed to be amped and ready.
Maybe
Temper looks like he's gonna sleep.
maybe it's because that the mind is like thinking about tomorrow.
You see this here? You take it now, right? You understand it. You know it. And then you put it in a box. And that box, you don't put it far away, right? Because that box is coming on Sunday, right? Then your other box of all the stuff you learned from module 1 to 5 or 4, you put that box on. You use that box tomorrow.
Different boxes. No, different boxes. Because so many boxes, right? We've got a whole lot of boxes.
Now you need to go dig now which box it is now. Okay. Let's do the one where they do 2 sine 2x, right? Because you're not sequencing.
Can we also maybe, is it actually possible for us to draw the graph? Just so that we can
I'm gonna do one when I draw the graph later because of I need to check.
I think it'll make more sense about the whole turning points
And
and
yeah.
minimum, maximum, exactly, because right now, as you're saying, it's not making sense because you're having turning points, but you're saying minimum, maximum points, but it's like, but it's not.
You know what you're mixing it up with? You're thinking it's straightforward, straight from this here.
Yeah.
When you derive, right? That's when it changes. You'll see when we're doing this example on what you call this one? Sine, right? Okay, can I see this one? So, calculate the maximum. I'm on the bottom of page 227, right? Calculate the maximum and minimum points of y is equal to, I'm far to sleep with y is equal to 2 sine 2x. 2 y is equal to 2 sine 2x. Okay?
And you got the limits.
And they tell you that it lies between 0 degrees less than x less than 350. Okay? Why they gave us these limits? Remember with the cos graph, a sine graph. There's more than one turning point, right? You go up, you come down, you go up again, you come down, you go up again, you come down, right? So they want you to calculate the turning points that will obviously lie between 0 degrees and 350. Okay, so let's write it in terms of f of x. So f of x is equal to 2 sine the function of my independent variable, which is x, is equal to the equation. So for a maximum, for minimum point, I need to let my first derivative equal to 0. So I need to derive this equation. Okay? So this is, I'm going to write on the full one for this, right? d over dx of 2 sine 2x equal to 0. And then this is the constant 2 over dx sine of 2x equal to 0. What's the derivative of sine of 2x?
No.
Sine of 2x.
We don't have one.
No,
You were also in classes, didn't you? And you're telling me one.
no, I'm just trying to.
Before we carry on, right? Oh, we carry on. Right?
Cosine.
Yeah, before we carry on.
What is this? It's a function
Function of a function.
of a function.
Second.
Yesterday's lessons was, right?
Yeah.
So you will get this derivative from formula 16 to 25, somewhere there. It's the formula you're looking for is the derivative of sine of f of x, which is
Cos f
F of x times.
So
cos f of x.
it's cos f of x is cos of 2x times
D
F of x.
I don't know how you say this thing.
f of x, d over dx of f of x.
Yeah.
Right? So you just need to derive this part here. If you derive this, it's going to become times 2 equal to 0, which is because this is cos 2x times 2, this whole thing times 2. So I just multiply the 2 and then multiply each that, right? I got cos of x. So now we got the first derivative. Okay? This is the first derivative. This here is f prime x. We get it equal to 0. Now we're solving for x, right? So cos of 2x is equal to 0, because if you divide by the 4, you're left with 0. Now, what? Remember, this 4, if I'm dividing by the 4, I'm left with 0.
Okay.
Then, cos of 2x equal to 0.
Right.
And remember 0 points?
For cos.
Minus 270, 90, 270.
Minus 270 minus 90, 90, 270, and then you just keep on adding 180, right? Okay. So the 0 points here, everything comes together, I guess. Would be, but remember your range, right? Between 0 degrees and 350, right? So your answers for x needs to lie between them. So we know we're not going to use the negative numbers already, right? So we'll start from 90. So 2x is equal to 90 degrees, x is equal to 45. That's one value of x. 2x is equal to 270. X is equal to 1. We're still within the range. So we still need to keep on going until we come to a point where we're out of the range. Okay? 2x is equal to 450. Because from 90 to 70, 450, you keep on adding 180 for the 0 points, right? And then x is equal to 2 to 5. Keep on going again. Because we're still within the range, right? 2x is equal to the 630.
Can we do this?
X is equal to 315. Now we are at that point in the range. This is from trig when we were doing
I know what I'm saying. We did this exact one. It feels like we did this exact one.
Yeah.
when you-
Yeah. see?
yeah, we did this in a trig question. We did this when we were drawing graphs
Under the
for
graphs.
cos of 2x because we had cos of 2x somewhere along there, right?
The revision.
Yeah, the revision.
Probably, right? But don't mix it up with the division, right? X is equal to 315. What's the problem with that one? Our limit is x less than 315. So you can't use this value, right? So this one is not applicable. Okay, so now we got our x values. Substituting the x values into your original equation will give you your y values for your turning points. Okay? So for your turning points, for f of 45 degrees, this is equal to 2 sine of 2 times 45 degrees, yes? f of 135 degrees is equal to 2 sine of 2 times 135 degrees. And then f of 2 to 5 degrees is equal to 2 sine of 2 times 2 to 5 degrees. And then what you get for these numbers? You get? You should end up with 2 minus 2 and 2. Okay? Okay? My turning points are 45 degrees and 2, 135 degrees and minus 2, 2 to 5 degrees and 2. That's my turning points. Okay? Now we know that. How do we know which value is a maximum turning point? Which value is a minimum turning point? What do I need to do? You need to do the test to distinguish. So, your test to distinguish would be equal to the second derivative, right? So your f of x was equal to 2 sine of 2x. First derivative, we worked it out to be 4 cos of 2x. Your second derivative, derive this. Remember, it's a function of a function. So you're looking for the rule that has cos of f of x.
It's minus sine.
Minus sine.
Okay, so remember, okay, this is what we're doing, right? So we deriving 4 cos 2x, right? That will become 4 into d over dx cos of 2x. This will be 4 into, so what the formula says?
Minus sine.
Minus sine of f of x, which is 2x, times
D over dx.
F of x.
2x.
2x, which becomes, so when you derive 2x, it becomes 2. When you multiply it there, it becomes 8. You end up with minus 8 sine 2x. Right? So this is the formula for f double prime x. So what do you need to do? You need to substitute your critical values, but these are my critical values, right?
No.
Those are my critical values. Okay? So substituting into them. So for f double prime of 45 degrees equal to minus 8 sine of 2 times 45 degrees, you get a number, right? F double prime of 135 degrees equal to minus 8 sine of 2 times 135 degrees, get another number. And then f double prime of 2 to 5 degrees equal to minus 8 sine 2 times 2 to 5 degrees. What's the numbers you get here?
8 minus 8.
Minus 8.
So this is 8 minus 8 and you're gonna get 8 here. Right? When you work it out, you'll see you'll get 8, right? So remember what we said. If your second,
Another way.
Minus 8.
Minus 8, 8, minus 8.
so this is minus 8.
Yeah.
Oh, then you'll end up there. Okay? Now remember what we said. If your second derivative is greater than 0, you end up with a minimum point. And if it's less than 0, you end up with a maximum point. So for here, because should I wrote this a little bit down, right? Maybe I should have it done. So f double prime of 2 to 5 is equal to minus 8 sine of 2 times 2 to 5, which is minus 8, right? So here, this implies that f prime of 45 degrees is less than 0. So this is a here f double prime of 135 degrees greater than 0. So it's a, and here f double prime of 2 to 5 degrees is less than 0. So it's a, okay. Now if you want to see how it would have looked, okay, remember this is how our graph would look, right? Because our range lies between 0 and 315, right? So from what we know from graphs, our amplitude would have been 2, right? And minus 2. Okay? Your period would have got cut, right? So it would have been 360 over 2, which is 180. That's going to affect obviously your your x-axis. But just for argument's sake, right? I'm just going to draw it roughly. Sine graph looks like what? It starts from 0 and it goes here, and it goes here, and it goes. It would have went more, right? But regardless, your 0 points would have been 0, 180, and 360. Now looking at this in a general sine graph, where would your maximum and minimum point? Where your maximum and minimum points would be found? At what degrees here? 270, right?
Yeah.
Which are what? Your 0 points for your cost graph, right? Which is why when we do this, when you derive your first and you make your first derivative and you let that equal to 0, you see what we were actually solving for. Cos 0 points. Because we're solving for turning points, right? And then what happens, it ends up so okay, because this graph was actually 2x, your period got cut, so your 0 points on your sine would have been at 90 and 180, right? So this would have been a 90 and 180. So that first derivative turned the graph into it changed the equation to a cos equation in order for us to get these points here. So this one here would have been 45 degrees and 2. This one here would have been 135 and minus 2. Okay? So you're seeing now how your first derivatives is used for your maximum and minimum values. You understand what I'm saying, right? Okay, now is it making more sense, right?
Yeah.
Okay? So you see how for that one where you said if it's if it's less than 0, then you're ending up with the maximum value. Here. You asked me, you said, well, how come if it's less than 0, we're still ending up with, oh, you don't mean? Okay.
Because it goes the opposite of what
Yeah.
it doesn't. It's also
It does. But do you understand the concept of what's going on? Is anybody confused? Completely lost? Must I do a recap of what I just did?
Yeah.
Okay. So,
Especially
I started off by reading the question. So, the question asked you to calculate the maximum and minimum points of y is equal to 2 sine 2x. Okay? So I did that and I wrote it as a function of my independent variable, which was x. Even if you didn't write it like that, guys, and if you had said y prime, 100%, I don't mind, right? As long as you're doing a first derivative. Remember I said this f prime x could be dy over dx, it could be y prime, it could be f of f prime x, right? It's fine. That is all first derivative. Okay? So you did that, and you know for a maximum and minimum point, you have to let your first derivative equal to 0. So what we did was we derived this f of x and we obtained our first derivative, which is here. This rule that we used here was rule number, help me, 17, right? So when you're doing this, yesterday's video will help you in understanding how we got to this, right? Function of a function, chain rule, okay? So, anyway, we got to our first derivative. You let that equal to 0 and you solve for your values of x. Because this is cos has numerous 0 points. So you have to use your 0 points here when you're solving for it. Okay? So we solved for each one. We found that this one here was out of the range, so we never used it. We used the ones that obviously fell within the range. We couldn't use minus 90 because 2x is equal to minus 90. 2x will be equal to minus 45. Minus 45 is out of the range, so we can't use them, right? We got our 3 critical values. Substitute your 3 critical values back into your original equation. You will get the y value for your turning points. These are my turning points, or my maximum or minimum points. I don't know which one is which, right? Which is why I do the test to distinguish between which one. And the test involves you calculating your second derivative. Calculating the formula for our second derivative, it's equal to minus 8 sine 2x. That's the formula for my second derivative. I substituted a critical value, or my x value of the turning point. Right? When I substitute it, the answer I obtain, if it's greater than 0, I have a minimum point. If it's less than 0, I have a maximum point, which is what I did there. And I'm able to obtain the information I need for the graph. Okay? Anybody completely lost? It's a bit much taking, but it's not the worst thing ever, right?
Yeah.
You'll understand the concept of everything.
No.
Yeah.
I'm trying to picture it now on the graph and it's making a little bit with those turning points.
I don't know where you put it.
Yeah.
How can your 0 points be equal to your turning points? Because 0 points is 45. Right?
Remember something, right?
Yeah.
Like what I said earlier.
Yeah.
This is a sine graph,
Yeah.
right? For the values of your maximum point, it's
Yeah.
found at 90 and 270,
Yeah.
which is the x values for the 0 points for your cos graph. Because I'm deriving, when I derive a sine graph, it becomes cos, or when I derive sine, it becomes cos,
Oh, so it would change it.
right?
Okay.
These are not points, well, the one I'm calculating now is not values for a cos graph, it's values for a sine graph.
Okay.
What I'm trying to explain is the fact that how you're getting these turning points is because if you look at 90 and 270, those are normally 0 points that's found for cos graphs. And in a sine graph, that's actually your max and minimum points.
Okay.
Okay?
Alright.
So don't confuse yourself, but remember, always go back to the first thing, which is what you're actually working with. First derivative, I'm going to keep on saying it, right? Your first derivative, if you solve for your first derivative in general, right? You're getting a gradient. Remember from what we did earlier, right? From first principles. Your first derivative gives you gradient. If you let that equal to 0, your graph is at a maximum point based on the theory I said earlier of at that point A, on the left hand side, my A was moving upwards with a positive gradient, right? And on the right hand side of point A, my A was moving downwards with a negative gradient. So at that highest point, where your velocity is 0, you're going to have a gradient equal to 0, which will give you the turning point of it. You understand what I'm saying? So, recap, first derivative gives you gradient, right? If you let that first derivative equal to 0, you will work out your maximum and minimum points. Your second derivative, if you work it out and substitute a value for x for it, and if that value that you obtain is less than 0, you have a maximum turning point. If the value you obtain is greater than 0, you have a minimum turning point.
What's our desk, the small one, bro?
That's fine.
That single desk.
It's in the computer room on the printer.
It's there.
The printer is on it,
Okay, let me get it.
right? Do you understand? Anybody completely lost? Okay. This one here when I came here, which rule this was? 16. Yeah. 8. Okay. Can you take out your picture? You can. You're sure you're okay, right?
Yeah.
Well, I won't sleep tonight then if I know you're.
No, we're not sleeping tonight.
No, you all can't. I'm gonna sleep tops. Right? But I need to be fresh for invigilation tomorrow. But don't. We'll talk about this after. Okay?
Something like
Okay.
Still recording.
So,
Let's see.
there was something in the message or something.
Timber.
It's not put your phone on flight mode.
Supposed to, eh? Okay, sing this out, eh?
Yes.
How are we doing on time there?
10 past 11.
We're gonna have a LED today.
Yeah, we're not doing science today. Science, I'm gonna start the new section on Monday. It's just that maths, because I don't want to finish late next week with maths. Because I won't have much time to do past the papers with you. I'm saying I need Thursday, Friday, Saturday past the papers. Okay? Okay. See on page 228. Yeah? 228. And there's not much left, guys. There's so little left. Like 6 pages. Okay? Page 228. They say when they calculate the point at which the gradient of the tangent to y is equal to 3x squared plus 4x minus 12 is 16. Okay? So the equation that they gave you is y is equal to 3x squared at y is equal to, no, it's not y, at 16. So they gave you the gradients equal to 16. So they want to know at what intercept, at what value of x and y would the gradient of that graph be equal to 16. Which formula will be gradients? Your first derivative, right? So what we need to do to this, we need to derive it, okay? So dy over dx will be equal to d over dx into 3x squared plus 4x minus 12, right? dy over dx is equal to d over dx of 3x squared okay? So, derivative of 3x squared and then derivative of 4x 0, right? So, this here is actually your gradient formula. First derivative is gradient formula. Right? They told you they want to know what is the value of, what is the point, so your x and y value, and the gradient equal to 16. So you would get 16 equal to 6x plus 4, take it across, you end up with 12, divide by 6, you end up with 2. So your x value is equal to 2. How would you get your y value? Put it back in your original equation. So y is equal to 3 times 2 squared plus 4 times 2 minus 12. 2 squared is 4 times 3 is 12 plus 8 minus 12, cancel, 8. So the coordinates of the gradient equal to 16 is at 2 and 8. You understand it? That's not difficult, right? That's just me reminding you that the first derivative is your gradient. For maximum and minimum points, you let that gradient equal to 0. Cool? Right. Now let's look at point of inflection. Okay? Point of inflection on page 230. You want to take a picture of this? congratulate me now. You're okay with me.
Can I have, wait,
Wait.
yeah, I need to have some water.
Okay. Now have a break. Take a pause. 200 pause.
1 minute break.
How you can say that about that?
I
don't hear you.
But I do like it. But
I can see that.
I like chemistry and stuff, so I enjoy that stuff.
See, you're talking fast with that. Wait, I'll be back. My back is all broke. Right. Let us do point of inflection. Okay, so this is point of inflection. So they tell you calculate the minimum and maximum points of y is equal to x cubed minus 4. Okay? So the example is y is equal to x cubed minus 4. Right? So on page 230, right? So calculate the minimum and maximum value of y is equal to x cubed minus 4. So f of x is equal to x cubed minus 4. For a maximum or minimum point, your f prime x, or your first derivative, must equal to 0. Derive the equation.
It's 3x.
So you're left with 3x squared. X cubed, 3x to the power 2, and the derivative of a constant is 0. You let it equal to 0. X will be equal to 0 because you divide by 3, which is 0, and you square root 0, which is 0. Now, to get the turning point would be substitute back in your equation. So y is equal to 0 cubed minus 4. So y is equal to, so your turning point is 0 minus 4. Okay? Now to distinguish whether this is a maximum or minimum, we'll do the test. Okay? So f of x is equal to x cubed minus 4. Your first derivative is equal to 3x squared. Yeah. Okay? And then your second derivative is equal to, right? So for f double prime of 0, because that's our critical value here, right? This would be 6 times 0, which is 0. And remember, the rule is that if your f double prime x, or your second derivative, is less than 0, you have a maximum point. If it's greater than 0, you have a minimum point. This is equal to 0.
What's that word?
So what's that now?
Point of inflection.
That is your point of inflection. Okay? So on page 231, they tell you that at a equal to 0, at a f prime x equal to 0 does not satisfy the definition of, double prime, does not satisfy the definition of a maximum and minimum point. They tell you over there, point A is a point of inflection with the following characteristics. The curve changes direction at A. Okay, so the graph is figure 6.6. The curve changes direction. Your second derivative is positive before and negative after. Second derivative can also be negative before or after the point of inflection. Okay, I don't want you to know unnecessary theory, right? What I want you to know is that on the next page, they tell you at the top of page 232, for the point of inflection, d2y over dx squared is equal to 0. main thing. What the d squared y over dx squared means?
Second.
Second derivative. So if you want your point of inflection, you will calculate your second derivative and let it equal to 0. Are we all clear on that?
Yes.
Okay, so just to recap, right? You have a function, which is an equation. Your first derivative gives you what? Gradients. If you equate it to 0, you get 0.
No.
Minimum and
You get your minimum and your maximum points, right? So that's first derivative. We all clear on that? When you get your second derivative and you get an equation and you substitute your critical value, you are able to determine whether your minimum and maximum, or you're able to determine which of your turning points are your minimum and maximum. If you equate your second derivative to 0, you get your point of inflection. Does everybody understand that? Is anybody worried about that? Are you worried about tomorrow's test?
Yeah, this will come like to the picture.
Yeah, this is future yours problem. This is Saturday afternoon problem.
No, not Saturday.
This is Sunday morning's problem.
Yeah.
Right? So, yeah, as long as you're, and remember all these videos will be posted. Another thing I wanted to tell you is, because you're going to start learning continuously soon, right, for the exam. I'm going to send you all the link for the playlist for maths and science. So I'll just spending the morning time to sort it out, like the list in terms of the lessons being taught in the order and names and everything. So when I send it to you, you'll be able to access the playlist on YouTube, and then you'll be able to see from lesson 1 to like lesson 20 something. In order, it has names, it has a description of what's taught in that video. So if you want to basically go and look for graphs and you want to look at where we covered parabolas, you check which video it is, you can go, you can watch that thing there. So I felt like that will help you in your learning time, right? And then today's video I posted, so you'll have everything up until this point, right? Okay, so let us do an example. Ready for the example? Huh? Yeah. I like so this Okay. Can you hear something?
Yes.
You love putting C everywhere.
Hey, tricky.
Every section. C is somewhere there. I think we said
Tell us from the beginning that you must like to.
you must love C.
Now.
You must love it. You're gonna be in your life forever now. You're stuck with it now, right? So they want you to calculate the point of inflection for y is equal to 2 cos x at 0 degrees less than x less than 360. Equal to, less than equal. For both?
Yeah.
Okay. So, how you do it? I'm supposed to teach. Right. So, for point of inflection, what do we know about point of inflection? Your second derivative must be equal to 0. So we need to solve for your second derivative, right? So this here, if I write it in terms of x, it's a function of x equal to 2 cos x. Your first derivative will be equal to,
Minus 2 sine.
and I understand it, right? It's from your rules, right? This is not a function of a function, it's just a function. Okay? Minus 2 sine x. F double prime x is equal to minus 2 cos x. Because the derivative of sine x is cos x. Okay? And then minus 2 is the cos x. Minus 2 cos x. Right? And remember what we said? For point your double derivative must equal to 0. So minus 2 cos x must equal to 0. Then You divide, you get cos x equal to 0. Your 0 points. Where is cos x equal to 0?
Minus 270.
So in terms of our range, right? It's just 90 degrees and
270.
I don't need to do anything else because it's just x. I'm just gonna basically say x equal to 90, x equal to 270. These here are known as my what? Okay? Using my critical values, I substitute it back in my original equation and I get my turning points. So this would be f of 90 is equal to 2 cos x. F, before you use your calculator, what's the answer?
2.9.
Stop putting your calculator.
Can't remember.
What do you mean? What is this called?
Oh, it's 0.
It's called the 0 point, right? Because it's on your x-axis, your y value is 0. So these two values here would be and 0, right? So, sorry, these are not the turning points, these are your, it's just y values, right? So your point of inflection is 90 degrees and 0 and 270 degrees and 0. These are not degrees, these are y values. Okay? Do you understand what I did? I just did my second derivative, then equal to 0.
Yes.
Okay. I feel like every time I do this, you're going to end it your tongue breaks or something.
So this point of inflection, you remember the previous example, when you're substituting, it gave us 0.
Yeah.
Right. So why calculate it? Because when you do that method, it's going to give us 0. Why do? You remember I said
When I did that example for maximum and minimum,
second derivative.
that the one when I started teaching it, right? That was, they just wanted to show you exactly like how I told it to you. You know, like how when I said calculate the maximum minimum, and then I said we came to this point, f of a, the second derivative must be less than 0 for it to be this, but it's equal to 0. They're not going to give you a question where you calculate your second derivative and you get an answer of 0, because they were trying to explain the concept of point of inflection. So you will get an equation, but what they want you to do is calculate the points of inflection. You see that one they gave us, why it ended up like that was because it was, where's the example? That x cubed minus 4, right? Because you have no second term. Yeah, because you have no second term, or, yeah, you end up with that.
0.
Yeah. So it cancels off to 0, 1, 10. They'll give you probably a trinomial. No. Yeah. Or cubic function. Okay? But yeah, they won't give you one. Like I was just to explain the concept of it. Cool. But in that example that you said, I'm gonna check out and tell you tomorrow, right? I'll check out whether it counts as a maximum one or whether it's just an inflection.
So if there's no maximum minimum value, that's second order, then we use this.
No. They can
What
ask
does this
you.
mean exactly?
This here.
Inflection.
Point of inflection is on the previous page where they tell you on page 231, right? This is a value of positive. Okay, so at the point of inflection in the above case, this is a value between positive and negative, and it's a special case, right? That's why that one became straight. You have no maximum minimum points, right? Your inflection point is where your point changes, your curve changes direction. So if you look at the graph, right, their point of inflection was at 0 and -4.
Yeah.
So you see it was curving up, but then it changes the way it's going up. Okay, it's the point at where your graph will start to change its direction. For some graphs, like your sine and cos graph, it also looks like a point where you can basically drop your graph into the other. So like say over here, right? And if your point of inflection is here, right? If I take this portion and I turn it like this, it's gonna fit into that spot perfectly. You know what I'm saying? Right? That's also what your point of inflection could be. It could be the point where your graph starts to change its direction in values. Like see here, it starts decreasing, but then as it starts going down from this point onwards, it starts the new wave, which will start the increase or something like that. Right? So the order of it is, first derivative will give you gradient. If you let that equal to 0, it gives you your turning points. Second derivative, if the value is greater than 0, you get a maximum point for your turning points. Right? Minimum, sorry. And if your second derivative is less than 0, you get a maximum. If you let that equal to 0, you are basically solving for your point of inflection. So your point where your graph changes direction, something like that. We all together? We are understanding? Yes.
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 You'll hear more from us next week.
Okay. Tranquilly, there? Oh shit.
Oh, it's gone.
You sure?
Oh, no.
Shit. Wait, I took out half of what I wrote. So this would have been cos x equal to 0 because I would have divided that. And I would have said 0 points here.
X equals. Yeah.
Oh, you could have just went back to the video and saw what was on the screen for the last 10 minutes there. I'm going to do one more example and then we'll stop here for today, right? Okay. But before I get, do you understand the concept of what I did today?
Yes.
Maximum and minimum and the point of inflection, how to get these things.
Yeah.
Because they'll ask you in your derivative section one question on this, they always. So they'll ask one on that limits, with the form 0 over 0 and infinity over infinity. One with the first principles, more or less, plus my hour paper will be set in there. They'll ask you one to simplify using your differentiation rules. So you know the table and stuff. They'll ask you a product and a quotient rule question, or maybe a chain. So avoid maybe a chain in a product rule question, and then they'll ask you one like this. And you'll know all this stuff. Okay? You'll do know it. Right? I'm taking it. Don't doubt yourself when you're going to paper. You'll know the stuff. When we're answering examples in class, it's you all answering it, I'm just writing on the board. Even that to us, this way, I can't even speak English. Right? Ready?
Yes.
Calculate the point of inflection of y is equal to x to the power 4, 3x cubed plus 3x squared plus 2. Right? So, y is equal to x to the power 4 plus, I forgot?
3x cubed plus 3x plus 2.
Right, you're all solving this, right? They want to know the point of inflection. What you do? If this came out in your exam and you all were answering this without the stress now because you're calm, right? How would you answer that?
First derivative.
First derivative.
And the second derivative.
Can I write it in terms of x first?
Yes.
As a function of x, right? So a function of x is equal to x to the 4 plus 3x cubed.
You said we can't have y, huh?
Yeah. And then you could have said y prime after that. I don't know why you're like to differ from a method. Yeah, I'm so wrong of f of x, f prime x, and then, right? So what shall I do now next?
Derive.
Derive.
F prime x. What's that? 4x
cubed.
6. Yeah.
Yeah.
Okay?
Yeah.
Do the second
Second derivative.
Yes, boss. Right?
Times 2.
12
Well,
squared plus
18x, that's it.
That's it.
That's six.
Oh,
6.
yeah.
Yeah.
And let's
Equate to 0.
let
So?
it equal to 0.
Yeah. Yeah. Then
Zero.
factorize
Factorize
to get the critical value. Wait. Yeah.
Oh god. Just
You
divide
can just
everything by 6.
divide,
X squared equals 2x plus 3 plus 1.
no.
9.
Yeah.
3.
Yes.
Divide by 6 or 2? 3.
Six.
Okay.
Divide by 6. Yeah. So it's going to be 2x plus 1 into x plus 1. So 2x is equal to half, x is equal to half, minus half, or x is equal to minus 1. X is equal to minus half, or x is equal to minus 1.
Oh, yeah. It's alright. It's fine.
That's fine.
I'm just checking. Yeah?
2x plus 1 equals to 0.
X is equal to minus half, that's half minus 1.
Yeah.
And what your critical values now is 2 for y.
Original equation.
And substitute that to the original equation. For f of half minus half is equal to minus half to the power 4.
So it's equal to minus.
Okay,
Minus half to the power 4.
minus half to the power 4 plus
3
Plus
times
the 3 times
minus half to the power 3.
That's 3 to the power 3 squared
Plus 2.
plus 2.
Nice if you could answer the exam like this. I'll write it down for y'all. You all tell me what to do, and then when somebody wants to go to the department, right?
1 over 8.
Oh yeah.
What's 1 over 16 plus 3 over 8 minus 3 over 8. It's positive 1 over 16 minus 3 over 8. That's plus 3 over 4 plus 2.
You want to write it down?
Let's see.
2 over 4.
Okay.
2.438.
Then,
Then you,
Substitute.
so now you go to y coordinates.
one
Minus 1 is 0.
Minus
9 minus 3. I feel like this is 3.
3.
It's 3. Okay. So your point of inflections is
Minus half. And 2 over 4, 3, 8.
And 1 minus 1.
1, 3.
okay. What I've successfully proven is that you'll know how to answer these things. Because it wasn't me answering it. Right? I just kept on saying go, okay. And you'll use it. Right? So you'll know the work. So tomorrow's paper, you'll also know the work. You're fine. Okay? We're gonna stop here for today. On Monday, I'm gonna do sketching graphs using a maximum and minimum value on page 234. And then I'm going to do sketching graphs with the form y is equal to ax cubed plus bx squared plus cx plus d on page 237. And then guess what? We're done with limits and differentiation. And then we just got integration and then we out. Right? So far we've covered a lot of syllabus and you can see that you'll know how to do it. It's just obviously a lot to take in at once. And the only way to get better at it is practice. Okay? Pass your papers and practice. Is there any questions on what we did today?